Okay, now we revise this question again. Okay, fourth one. So in this question we can say that the two vehicles 100 meter apart from each other, if they travel in the same direction, they meet after 5 hours. Okay, and if they move in the opposite direction, they meet after 1 hour. Okay, then find the speed of these two vehicles. So we assume here that let the speed of car A is x kilometer per hour and the speed of car B is y kilometer per hour. Okay, so just we are assuming the speeds x and y, it is x kilometer and y kilometer per hour. Okay, now when both the vehicles are moving in the same direction, okay, maybe we can say that if they are moving in this direction, then the speed of car A, that is x kilometer per hour, is greater than y. Okay, and so this will move with a certain speed. Suppose we can say it is moving with 100 kilometers per hour. Okay, and this is moving with a 60 kilometers per hour. So they will meet after a certain time. That means after 5 hours they will meet. When they start, means the starting time is same. That suppose this will start at 12 o'clock, this is also start at 12 o'clock. So when in the same direction they are moving, we can say that for finding the time, we have to subtract the speeds. Okay, so here when both cars are moving in same direction, speed is equal to x minus y kilometer per hour. Okay, x total speed minus y speed. Okay, and then they will meet. So it is a x minus y. Now speed is equal to distance upon time. Speed is equal to x minus y, distance covered. Okay, so that we don't know here. Distance remain d. Okay, and timing we can say it is a 5 hour. Okay, so therefore d is equal to 5 x minus y. Okay, this is the first one we consider. Okay, and the distance traveled is, we can say that this speed and minus this, so distance traveled will be 100 kilometer only. Okay, so here we can replace d is equal to 100. Okay, so therefore if we divide by 5, then it is 100 upon 5 is equal to x minus y. So therefore x minus y is equal to 20. Okay, second, when they are moving in the same direction, okay, both are moving in opposite direction, speed is equal to x plus y, because x and y both are added and somewhere they are meeting. Okay, so therefore speed is equal to total distance traveled is 100 and timing is 1. So it is x plus y is equal to 100. This is the second equation. Now these two equations we have to solve by cross multiplication method. Okay. So further process you know how to solve it. Okay. So just go through this one. Okay. And after this one more is given. That is about maybe the area of the rectangle. Okay. Next is fifth one. The area of the rectangle gets reduced by 9 square unit if its length is reduced by 5 unit and breadth is increased by 3 unit. If we increase the length by 3 unit and breadth by 2 unit, the area increases by 67 square unit. Find the dimension of the rectangle. Dimension, that means length and breadth. So here we can assume, let the length of a rectangle be x and breadth of a rectangle be y. Suppose we can say this is the rectangle, length is x and breadth is y. So therefore area is equal to what? L into B, and that is xy. Okay. Now here we are saying that area is reduced by 9 square unit. Area reduced, this area reduced by 9 square unit if its length is reduced by 5 unit. Okay. Length is reduced by 5 unit. Length is actually x. Now we are reducing it by 5 unit. And breadth increased by 3 unit. Then the area reduced by 9. Area is xy, it reduced by 9. Okay. We open this bracket xy plus 3x minus 5y minus 5 is a 15 is equal to xy minus 9. Xy cancel. So this is 3x minus 5y. 15 we are changing to opposite side. So 15 becomes positive. 15 minus 9. Okay. So it is 6. So this is the first equation. Now second, it is given that if we increase the length by 3 unit, length by 3 unit, so we increase it by 3 unit and breadth by 2 unit. Okay, breadth by 2 unit. So it is, the area will be increased by 67 unit. Okay, so this is the second equation. So first xy plus 2x plus 3y plus 3 to the 6 is equal to xy plus 67. Xy cancel. So it is 2x plus 3y, 6 will shift over. So remain 61. Okay. So these are the two equations. Now we have to solve it by cross multiplication method. Okay. So this is about the problem sums of exercise 3.5. Now we switch over to exercise 3.6. okay, so just go through this question. Okay, the rest portion you have to solve yourself. Now in exercise 3.6, a little variation is there. Okay, and that is, we can say that our variable is at the denominator. Okay, so exercise 3.6, solve the following pair of linear equation by reducing them into the pair of a linear equation. So first, suppose we consider it is a 1 upon 2x plus 1 upon 3y is equal to 2, and 1 upon 3x plus 1 upon 2y is equal to 13 by 6. Okay, see here in both the equation, the variable x is at a denominator, y is also at a denominator. So in this case we can say we have to assume 1 upon x and 1 upon y. That is a simple way. So suppose we can say let 1 upon x is equal to a and 1 upon y is equal to b. Okay, so here what happens, 1 upon x is equal to a. So in equation 1, 1 upon x is equal to what? A, and 2 remain as a denominator, plus 1 upon y is equal to b, and 3 as a denominator. So this is the equation. So now our variable becomes numerator. Okay, now take LCM. So it is a 6, 3a plus 2b is equal to 2. So therefore 3a plus 2b is equal to 6, 12 to the 12. Okay, so this is the first equation. In equation 1 upon 3x plus 1 upon 2y is equal to 13 upon 6. 1 upon x is equal to a. So it is a upon 3 plus b upon 2 is equal to 13 upon 6. Take LCM. So it is a 2a plus 3b is equal to 13 upon 6. 6 cancel. So it is 2a plus 3b is equal to 13. Now these equations you can solve by any method. Okay, just I am solving it by elimination method. See here I am considering b. So here the coefficient is 2 and here coefficient is 3. So just multiply by this coefficient to the whole equation and by this coefficient to whole equation. Okay, so here I am writing multiply equation 1 by 3 and 2 by 2. So therefore 3 3s are 9a, 3 3s are 9a plus 2 3s are 6b is equal to 12 3s are 36. Okay, here it is multiplied by 2, so it is 4a plus 6b and this is 26. Now change the sign. So 6b cancel, 9 minus 4 it is a 5a is equal to 36 minus 26, so it is 10. So therefore a is equal to 2. Replace this value in any of the equation. Okay, so suppose in 1 we are replacing, so it is 3 a is equal to 2 plus 2b is equal to 12. So 6 plus 2b is equal to 12. So 2b is equal to 6 and therefore b is equal to 3. Okay. In this equation, we are replacing the value of A. So 3 2s are 6. Switch over. So 2B is equal to 6. So B is equal to 3. But now actually we have X and Y. So first A is equal to 1 upon X is equal to the value. It is a 2 by 1. So therefore X is equal to 1 by 2. 1 upon X is equal to 2. So X is equal to 1 by 2. Inversing both this. Okay. Similarly, B is equal to 1 upon Y is equal to 3 upon 1. So therefore Y is equal to 1 upon 3. So this is your solution. X is equal to 1 upon 2 and Y is equal to 1 upon 3. Okay. So this is the first question of exercise 3.6. Okay. One more we will try, that is of a square root. Maybe. So second one is of a square root. So it is 2 upon root x plus 3 upon root y is equal to 2. And second is 4 upon root x minus 9 upon root y is equal to minus 1. Okay. Again here let 1 upon root x is equal to a and 1 upon root y is equal to b. So therefore this equation 2a plus 3b is equal to 2. Okay. And here it is a 4a minus 9b is equal to minus 1. Okay. Now for b we can say this is a 3 and 9. So if you multiply this equation by 3, 3 is a 9 and opposite sign is there, so no need to change the sign. So multiply equation 1 by 3. So therefore 3 2s are 6a plus 3 3s are 9b is equal to 3 2s are 6. 4a minus 9b is equal to minus 1. So it is 10a. 6 plus 4, 10a is equal to 5. So therefore a is equal to 1 upon 2. Okay. Replace this value in any of the equation. Okay. Equation 1, suppose this one. So 2 into a is equal to 1 upon 2 plus 3b is equal to 2. 2 to cancel, 1 remain. So therefore 3b is equal to 1 and therefore b is equal to 1 upon 3. Now a is equal to 1 upon root x. And what is the answer of a? 1 upon 2. So therefore root x is equal to 2. Both are inversed. Okay. So root x is equal to 2. So therefore we are making a square. From root x we require x. So we are squaring this side. So we have to square on the other side also. So x is equal to 4. Okay. Similarly we can say b is equal to 1 upon root y is equal to 1 upon 3. So therefore root y is equal to 3. So making square. Square of 3 is 9. So x and y are 4 and 9. Okay. So this is the additional exercise, or we can say that it is a special type of sums. Okay. So now rest of the first questions, that is total 7 are given. So this you have to try yourself, okay? If any doubt is there, then in the next lecture we will solve it, okay? Then maybe we can say problem sums are there. So here in question 2 we can say one doubtful question is there, maybe little bit tough. Question 2, its second question. 2 women and 5 men can together finish an embroidery work in a 4 days. Okay, so that means 2 women and 5 men together, that is total 7 persons if works, then one embroidery work is completed by them in a 4 days, while 3 women and 6 men can finish the same in a 3 days. Find the time taken by one woman alone to finish the work. Means in place of the 7 person, if only one woman is working, then in how many days she is capable to finish the work, and also taken by one man also. Okay, so here first we assume, let the number of days taken by a woman to complete one work is X days. Okay, the embroidery work is considered as a whole work, one work in a X days, and the number of days taken by a man to complete one work is Y days Okay, so one woman alone can complete the whole work, that is the embroidery work, in a X days, and alone one man can complete the embroidery work in a Y days. Okay, so therefore here we can say that in one day work done by a woman is 1 upon X work. Okay, means suppose here we can say that the woman is capable to complete the work in a 20 days, suppose. Then in one day how much work she will complete? 1 upon 20 work. Okay, similarly for the man, in one day work done by a man is 1 upon Y work. Okay, complete. Now what is there in the question? Can 2 women and 5 men, okay, can complete the whole work in a 4 days. Okay, so here we assume that let 1 upon X is equal to A, 1 upon Y is equal to B. So therefore 4 into 2A plus 5B. Okay, so therefore 4 2s are 8A plus 5 4s are 20B is equal to 1. This is the first equation. Okay, similarly we can say what is it? While three women, okay, so three women together they can complete in a one day 3 by x work, okay, and 6 men, okay, they complete the work in a 3 days. The whole work is completed in a 3 days, okay. So again here we can say it is a 3a plus 6b is equal to 1. So 3 is a 9a plus 6 is a 18b is equal to 1. This is the second equation, okay. So now by any method you have to solve this equation, okay. So then you will get the answer, okay. So here I think almost questions we have covered, okay. So now you have to complete your exercise number 3.3, 3.4, 3.5, 3.6, okay. No additional exercise at present needed, okay. So up to this you have to complete, and if you find any doubt in this exercise then please ask me in a WhatsApp group, okay. So I will answer that particularly, okay, as well as the examples given in between, that is before 3.3 exercise, 3.4 exercise, 3.5 exercise and 3.6 exercise. Whatever the examples are given of a different methods that you have to solve, okay. So after completing the exercise you have to start examples, okay. So here we are finishing our work of this chapter, okay. Now we will move to the next chapter, that is the fourth one, which is similar to this one, or we can say whatever the problems of this chapter can be solved by the quadratic equation also, that is the fourth chapter, okay. Remaining, that is we can say graphical method later on, okay, we will solve, because generally till now in board examination they are not asking question from the graphical method, okay. Generally they are selecting remaining three methods, okay. So later when our classes will reopen, practically we will complete the graphical method, okay. So at present we are starting the fourth chapter, quadratic equation. See, in this quadratic equation we can say the standard form is ax square plus bx plus c is equal to 0, where a is a coefficient of x square, b is a coefficient of x and c is a constant term, and the condition must is where a is not equal to 0. If a becomes 0 then it becomes a linear equation of one variable bx plus c. So variable is only one and having a one power, so it is a linear equation of one variable, okay. So this is a standard equation, okay. Now solution methods, we can say there are three methods given in our textbook. One is the factorization method, okay, which we learned earlier also. Second is a completing square. Method. This is also similar to factorization, but little bit different, and it is most complicated method, okay. And third is considered as a formula method. This method was developed by an Indian mathematician Sridhar Acharya. So this is also considered as a Sridhar Acharya method, okay. So this is the basic fundamentals of a quadratic equation. Okay, later we will discuss, just you have to go through this. Maybe we can say that when we start our mathematics chapter, this will further. Okay, in between, maybe in your school videos it may be completed, but I will try as earlier as possible to finish this chapter. Okay, so today just we go through the basics of this chapter. Okay, once you finish your homework, within that we will start this chapter as early as possible. Okay, so thank you for today, and this is, I think, second chapter we have finished. Third chapter. Okay, first we have taken this one, statistics, 14 chapter, and now this is the third one is completed. Fourth we will continue now. Okay, till that, thank you very much.